Chapter 7. Lipids are basically fats. And fats kind of get a bad reputation. Chapter 7. They're not all bad. Right back there with the cardiovascular, or excuse me, the carbohydrates. The American people have kind of made them bad. You know, too much of a good thing is always bad. Lipids are present in all tissues, and they do have important things to do. Okay? They are an energy source, not all of them. Some of them convert to hormones, and we know those are really important. Some of them are important for cell membrane structure, for the cell walls. And some of them are important for nerve insulation. Well, those sound like some pretty important jobs that we need fats for, okay? They are organics, and they have carbons and hydrogens, so no nitrogens. And they might have some oxygens. One characteristic about them, and it just makes sense to us, especially if we've been in the kitchen, that they are soluble in organic solvents, but not very soluble in water. And we call that hydrophobic. Most of them are not soluble. Oil and water do not mix, okay? And their significance for us is excessive amount, which is usually due to consumption, is related to cardiovascular disease. Okay? They're broken up into 5 main categories. There again, it depends on the source that you used. Your textbook has these 5. Sterols, which the one we're interested in is cholesterol. Fatty acids, glycerol esters, and we're mostly concerned with triglycerides. And then sphingosphene and terpenes, but we're not going to get into those last 2. Please remember, lipids are quite a few different things. There is not one triglyceride. There are triglycerides. Okay, so we're talking about more than one form. And we kind of lump them together. First, let's talk about cholesterol. It's a sterol. And it is found in animals, including us, human beings. It's pretty big. It's got 27 carbons, and it's got 4 rings. See the rings here? Cholesterol is not an energy source, but it does have important functions with the cell membrane, and it's a precursor for bile acids and steroids relating to our hormones. And sometimes it is amphipathic, meaning sometimes it likes water and sometimes it doesn't. So hydrophobic and hydrophilic. Fatty acid are really your simplest of the fats, of the lipids. That formula looks pretty similar. You got your COOH with a radical attached to it. Some of them are free, meaning they have a charge missing. But most of them are bound to make triglycerides for energy. And we're going to talk a little bit about saturation and unsaturation. Okay, you didn't know this was going to be a nutritional class. I have a handout to give you to kind of help with this concept. Okay, saturation. Think of this chain. You guys, we got enough? You don't want more fats? Saturation means there are no double bonds, okay? The C's are filled up with hydrogens. Double bonds, and I don't know if we'll have time to get our models out today, but I've got to take them back. When we made double bonds, that made them flexible up to a certain point, okay? Saturated means just think of them as three-dimensional straight, okay? And that's kind of what this picture is trying to show you here. Nice, kind of straight. They don't have double bonds. They don't bend. Double bonds make them flexible, so they do bend. So they stack up nice and compact. What do you know about a dietary fat? Things that stack up and compact. Saturated fats we don't want in our diet. Okay? They're solid because they compact. There's not spaces in them. And they come from animals. We don't make them. They're this stuff, okay? Nice and compact. As opposed to unsaturated, okay? And now here is a picture of a double bond. And it's showing you with the double bond, we're bending. We have some flexibility and we bend up to a certain point, okay? So they don't stack as nice. And so they're a liquid state. You buy oil in the grocery store. Do you know what it says on the label? Unsaturated. Whatever it happens to be. You don't buy a bottle of liquid of saturated fat. Okay? And it comes from our plants. Does that make sense? That kind of explains the difference. So just from that, I'm going to say, well, I think I would prefer the unsaturated fats. Now, we've been hearing a lot in the news about trans and cis fats. Okay. First, let's throw in mono, unsaturated, means we have one of the double bonds, as opposed to polyunsaturated, meaning several double bonds. So several double bonds would make it really flexible. Okay. Well, this has the cis and trans on it. These are the ones we don't want. They are double bonded, but because, and if we could get to our models, we might be able to make some. You can kind of see it looks linear. So it's going to stack more. This is the fat that is really stable. Those of you who deal with any kind of cooking, what happens to your oils when they sit on the shelf after a while? They smell, they get that rancid. Come on, you guys cook or bake, don't you? Don't you pour oil in the pan to fry something? And have you ever opened one and it's rancid smelling? It's like, oh, I don't want to put my food in here because it's unstable. Well, we messed with the bonds to make it more stable and made them trans, and that's what they were selling in the restaurants to fry your food in. And then we've decided that those are just as bad as the saturated ones because they're straight, they're going to stack up. And I owned a bakery, so I know we had a donut fryer, and when the oil was hot, it was nice and liquid. But when we got it in on the truck, and it was a big cube, it's really thick, hard oil. And so just think about what that's doing inside your body, your veins, trying to pump it through there. Don't get cold. You need to stay warm. So Since then, they've decided, well, this is bad, so now we need to get rid of those. We're making them to keep them stable on the shelf, but now you're just going to have the rancid ones. They're working on more. They come up with more. So a cis unsaturated is better than a trans unsaturated for our bodies. Okay, moving on past the nutritional component. Glycerol esters. Anything ending with OL is an alcohol, and it is glycerol is a common alcohol in our bodies. It has 3 carbons. So 3 carbons are able to attach some lipids to them. And we get a triglycerides. So here's the 3 carbons of the glycerol. And here, each one of those carbons has a fatty acid attached to it. Okay? That's where triglycerides come from. Now, if you only have 2, it's a diglyceride, and it works a little bit differently. But these can all be different, hence triglycerides, we have more than one. We could have them all be single bonded like these 2, or we could have some double bonds, some of each. So our foods can be different. They can have different ones in them that we consume. Triglycerides are really based on your immediate ingestion, the levels that we measure in our blood. Okay, now it gets a little confusing. So we've talked about cholesterol, fatty acids, and triglyceride. Those are the main 3 that we're concerned with right now. Now we're going to go back to the protein lecture and bring some of that in here. We talk about lipoproteins. So what are you seeing in the word? We've got a lipid and we've got a protein, or a group. And a lipoprotein is the protein form of the lipid. So it's got a protein in it, and it's got a lipid in it, and it's transporting it. The lipoproteins are the transportation mechanism to get the lipids to different parts of our body. And we have a few that we are concerned with. Here's a nice picture. I think this is in your textbook. And look at it carefully. It's a mixture of stuff, okay? So this is blue is supposed to be the protein portion. The whole thing is the lipoprotein, okay? So it's lipids and protein all put together. And I don't think they're nice little round balls like this, but just bear with it. And then if you look at all the different colors, we've got some phospholipids, we've got some unesterified cholesterol, some cholesterol steroids, and some triglycerides. And there's some other things in here too. But it's a combination. So you ingest your food, and through the processes, it's going to get a protein connected to this complex. And the protein then is going to take it, transport it to different places. We have a few major categories, and it's based on density. When we first started doing this, we did an electrophoresis where we migrated the serum and used different parameters than we did for our proteins, and we could break up the different fractions and we found 4 different fractions. Actually, we found 3 because we didn't really care about the kilomicrons. But we got those bands, just like I showed you on the protein electrophoresis. So that's where we started with our lipoproteins, with electrophoresis separation into the different components. And they were based on density. Think about fat. It floats on water. And that's where we get the density that we're talking about. And these all have density in their name. We have high density, low density, and very low density. Okay? So if you could put them in a container with some water, you would be seeing them float at different levels. Chylomicrons is the biggest, it's huge lipid, and it's also the lowest density. So it's on the very top. Floats. Have you ever seen real milk where the cream goes to the top? It's up at the top like that. And it has a lot of lipid, most of which is triglyceride. Okay, so I made a picture down here. This red represents the amount of protein, and the yellow represents the amount of lipid. Chylomicrons is humongous, and it's almost all lipids. It's floating on the top. And it's usually from your immediate ingestion. So for the most part, we don't see this in people's blood, okay? Because as soon as it hits the intestines, it starts breaking it up. But with people who have malabsorption problems, you might see it. We don't see it usually right away. You might see some haziness in serum, or sometimes it actually looks like skim milk. But if you let it set and undisturbed, and especially if you put it in the refrigerator where it's cooler, it starts floating to the top. And you come back the next day and you can see this layer of cream on top. And I'll try to get some for you, but they're hard to come by. And that's how we used to detect them. We just put them in the refrigerator, 24 hours, come back, say, chylomicrons present, okay? But if they just ate a bunch of Big Macs and are a really bad person about their diet, that might not mean anything. But generally, if you have a chylomicrons problem, it is serious. And that's what it's saying here. Your serum's going to look milky, and it's really close to eating. That's why when we do lipid analysis, we want fasting. One of the reasons. The next one that's going to be right underneath of it is called very low density, LDL. It has a lot of trig and a little bit of cholesterol. So that big ball we were looking at, it has the different components. This one's a little bit smaller, okay? It has less trig, and now it's got more cholesterol and more protein. So it's a little bit smaller, but it's getting a little bit more protein. Okay? So it doesn't float as high. Don't worry about the intermediate. I don't really know much literature about it. It's a new one. The next one is low density lipo. It's a little bit lower than the very low. And it's starting to get more cholesterol and less trig. So here it is. It's smaller, getting more protein, less lipids, and more of which is cholesterol. Trig is from your immediate diet. Cholesterol is not. And then the very lowest one we call high density, HDL, has the lowest lipid content. So it has a lot of protein and not very much lipid in it. So I hope this graphic will help you. Don't be moving it around on your PowerPoint because it was really hard for me to get those all lined up, and they will be out of alignment if you mess with the slide before you print it. So I hope that helps you visualize why they have their names and what's in them. A lot of fat, a lot of trig, is your cholesterol, hardly no protein floats on top, big. And HDL down the lowest. Even though we're saying it's a high density, it's the lowest because it has a lot of protein and less fat. And here's some nice graphics I found. You can kind of compare them to each other, seeing their sizes, see how big this is compared to these little bitty HDLs. If you could actually look at them. Those look like they would cause problems, don't they? A big blob of oil. Okay, think about transportation and our big cargo load with your lipids. The chylomicrons are the great big freights, or the barges on the river. They have tons and tons of materials, supplies. sources from all over the place. And they bring it in, dock, and then your semis come in and they start loading up. Then your semis will take it somewhere where those are all distributed into smaller trucks. So your chylomicrons are the great big, mostly trigs that are coming in from your food, from the intestines, okay? They're going to be broken down or they're going to be stored. Then as they're breaking down into the very low density lipos, into endogenous trig, and even further breaking down, they're smaller, more compact. And then the LDL, this is a critical one. It is taking the lipids to the tissues. Okay, LDL, major transporter of trig to your peripheral tissues. It is an atherogenic problem. Okay? We don't want very much of it because it's taking the lipids to stay in our tissues. Did you get to see any foam cells in hematology? Foam cells are blood cells that are full of fat. They look foamy. And they're a great indicator for cardiovascular disease. They're plugs. They're bad. So we don't want very many low-density lipos because it's taken this cholesterol to places in our body. Mostly our vessels is what we're worried about. Well, then we have a cleanup team. Think about this. We've got all this mess that's gone out to all the peripheral roadways, the arteries and veins. Now we need a cleanup crew, and that's what HDL does. It doesn't have hardly any lipids in it. Remember, it was a lot more protein. It's small. It's kind of like your street cleaner. It's going to come along and pick up those lipids. Where LDL has dropped it off, it's going to pick it up and take it back to the liver to get rid of it. So we want a lot of it. We don't want very many LDLs to take it out to the little streets all over our body, but we want a lot of HDL to clean up that mess and take it back to the liver to get rid of it. Okay? Does that make sense? HDL is our friend. You have this chart, and it is showing you different percentages. The chylos, look, it's 84% trigs, hardly any of the outside the protein part, so to speak. Okay? And they decrease in trigs and increase in cholesterols until you get down to here. Okay? Then the HDL doesn't have much of anything because it's almost all protein. So it kind of helps you see the differences between each of these lipoproteins. Okay, now it's going to get a little confusing if you weren't already confused. We have the lipids, then a protein comes in and makes a lipoprotein, so it's a combo for transportation, okay? That protein is, the protein portion of the lipoprotein is an apolipoprotein. It's like, okay. Apo, if you see apo in front of any word, it means protein. A protein, if you will, okay? So we've broken it down even further. They're saying, okay, if you've got the certain kinds of protein, some are good and some are bad. Well, not really bad, but some are better than others, I guess you might say. And this is just going to go through different parts of it. What I want you to know is that we have 5 categories that we know of so far, and there will always be more. So ApoA, ApoB are the two newest ones that we have the most information about. Okay. And under each of those, then we've added letters. And they have decided that ApoA, this is the protein portion of HDL, makes up 50%. And if you have a lot of ApoA1, it is good because it is anti-atherosclerotic, okay? So ApoA1, and that's usually how they actually write it, is good. ApoB is everywhere except in HDL. So ApoB100 has become a risk indicator. The higher it means you've got more of the other ones than HDL, and we don't want more of those, which makes sense. If the ApoA1 is, most of it is with HDL, we want more HDL, and that's what's making it good. So if we broke down the HDL and just measured the ApoA1, we want it high just like we want the HDL to be high. And the ApoB100 is with the heavier guys, and we don't want more of it. Because if we have more of it, then we have more of the LDL, which is the bad guy that takes the fats and leaves them to clog up the sewer. But we don't know much about the rest of them. So those two, you're going, oh, I know. And you have this chart. Okay, and here you can see, well, here's the ApoA1, and then ApoB100 is showing you all these. It is important because it squeezes in between spaces, compacts in all the little holes, and creates inflammation. Then your macrophages are coming in there to try to get rid of it, and that's where you get your foam cells. Okay? And what did we say back on the protein lecture about the segs depositing, stickiness, debris, if you will? This comes into play with it. So this is the beginning of plaque buildup on your arterial walls. Okay, the fat, because of the ApoB100, has squeezed into these places. The blood white cells come in to try to clean it up, and we've got this mess, the stickiness, and then it just starts compacting on top of itself, making a big plaque. Is that a...